The ages of children in a creche are tabled as follows. So the ages are the top row. They go from 1 up to 5. And the frequency is the bottom row. So 1 child is 1 year of age. 0 children are 2 years of age. 2 children are 3 years of age. 2 children are 4 years of age. And 5 children are 5 years of age. Show that 4 is the mean age and then calculate the standard deviation. Okay, so this is the table that we're going to set up. MIV stands for mid-interval value. This is not a grouped frequency table, so we're not actually going to have a mid-interval value or a midpoint. We're just going to list our x values. So our top row is going to be our x value. So we have 1, 2, 3, 4, 5. So our x values are going to be 1, 2, 3, 4, and 5. Then our frequency row is going to go underneath F, which stands for frequency. So we've got 10225, so 10225. We need to add up the frequencies. We add them up and we get 10. Next, we're going to work out x multiplied by f. So we're going to multiply our x values by our f values. 1 multiplied by 1 is 1. 2 multiplied by 0 is 0. 3 multiplied by 2 is 6. 4 multiplied by 2 is 8. 5 multiplied by 5 is 25. Then we're going to add them up. 1 plus 0 plus 6 plus 8 plus 25 is 40. Then to get the mean, we're going to say 40 divided by 10 is 4. So we've now shown that the mean is 4. So then our next column is the mean, which is x bar. So we just have 4 listed all the way down. Then our D column, or deviation or difference, is going to be our x values minus our mean. So 1 minus 4 is minus 3. 2 minus 4 is minus 2. 3 minus 4 is minus 1. 4 minus 4 is 0. 5 minus 4 is 1. Our next column is our deviation squared, or d squared. So minus 3 squared is 9. Minus 2 squared is 4. Minus 1 squared is 1. 0 squared is 0. 1 squared is 1. And our final column is fd squared. So it's going to be our frequency multiplied by d squared, or deviation squared. So 1 multiplied by 9 is 9. 0 multiplied by 4 is 0. 2 multiplied by 1 is 2. 2 multiplied by 0 is 0. 5 multiplied by 1 is 5. Next we add up this column. 9 plus 0 plus 2 plus 0 plus 5 is 16. Then we're going to divide 16 by 10 and get the square root. So the square root of 16 divided by 10 is going to be 1.26. So our standard deviation is 1.26. So now we have another frequency table. So we have number of pets along the top row and frequency along the bottom row. So 2 households have 0 pets, 4 households have 1 pet, 8 households have 2 pets, 4 households have 3 pets, and 2 households have 4 pets. We want to find the standard deviation of the data. So this is our table that we set up. So MIV again stands for mid-interval value, or midpoint. Since we don't have a grouped frequency table, we don't have to find the midpoint, so we just list our x values. So this row here represents our x values. So we've got 0, 1, 2, 3, 4. So our x values are 0, 1, 2, 3, 4. Our next column is F, so for frequency. So we've got 2, 4, 8, 4, 2. So 2, 4, 8, 4, 2. Our next column is x multiplied by f, so our x values multiplied by our frequencies. 0 times 2 is 0, 1 times 4 is 4, 2 times 8 is 16, 3 times 4 is 12, 4 times 2 is 8. Next we need to get our mean. So in order to do that, we're going to add up our xf values, we get 40, and then add up our frequencies, we get 20, and 40 divided by 20 is 2. So our mean is 2, x bar, our mean is 2. Next we want to get our difference, or our deviation. So it's going to be our x values minus the mean. So 0 minus 2 is minus 2. 1 minus 2 is minus 1. 2 minus 2 is 0. 3 minus 2 is 1. 4 minus 2 is 2. So now we have our deviation. Next we want to square our deviation. Minus 2 squared is 4, minus 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Remember, we should only ever have positive values here because anything squared is positive. And our final column is FD squared, so our frequency multiplied by D squared. So 2 times 4 is 8, 4 times 1 is 4, 8 times 0 is 0, 4 times 1 is 4, 2 times 4 is 8. Next we have to add up our final column. 8 plus 4 plus 0 plus 4 plus 8 is 24. So then we're going to divide 24 by 20 and square root it. So the square root of 24 divided by 20 is 1.1. So the standard deviation of this data is 1.1.